Hello, good Tuesday, happy International Women's Day, and thank you for zooming into the void for the month of March 2022 with the Danville Science Center, presented by Danakid Associates. I'm Science Ben, Immersive Experiences Coordinator at the Danville Science Center, and the coming of spring for the museum means the coming of butterfly season. In just a few weeks, our butterfly garden will be opening now that the weather at night is warming up enough for the butterflies to have a nice, comfortable sleep so that they are ready the next day to entertain and educate us. Currently, the weather outside of the museum is a little cloudy, but using the digital sky viewing software Stellarium, we can get rid of those clouds to give us an idea of what we can look forward to the rest of the day. Here we are, as always, outside of the Digital Dome Theater in the backyard of the Danville Science Center. Looking in the corner, we can see it's just a moment after noon on Tuesday, the 8th of March, 2022. We are facing the southern sky and taking a few steps back. If we look to the left, we see east. Look to the right, we see west. Gazing skyward, we can see that our sun, our central star, is a little less than directly overhead. As we move throughout the month, we will get one of two yearly opportunities for that to almost happen on the 20th. So here we are. This is what the sky will look like on noon on Sunday the 20th. On that day, the sun will appear directly overhead for folks living on or near the Earth's equator. At that time, globally, the ecliptic, that apparent path that the sun makes throughout the sky, will be lining up in a crosshairs with the equator, directly focused on the sun's disk. This marks the beginning of the spring equinox for Earthlings living in the northern hemisphere, Earthlings like us here in Virginia. After the 20th, as we move, the ecliptic will rise higher in the sky, resulting in longer days and warmer weather. The seasons are not determined by the weather. Unseasonable weather happens all of the time. In fact, typically common in summer months, we experienced thunderstorms this past January here in Danville. Conversely, it is possible to snow in the summer and has. In 2015 and 2016, Hawaii of all places, experienced snow in June and July on top of the volcano Mauna Kea. It commonly snows in June in Australia. Of course, that's when they experience winter. The reason for Earth's seasons has to do with our tilt on our axis at 23.5 degrees. This slight leaning on our side results in different amounts of direct sunlight reaching different parts of the Earth throughout the year. When the northern hemisphere is tilted away from the sun, we experience winter, while the southern hemisphere is tilted toward it, resulting in summer. When we're tilted toward the sun, we experience summer and the southern hemisphere experiences winter. Spring and fall result from the halfway points between being tilted toward and away from the sun. Being tilted towards the sun logically results in warmer weather. However, sun exposure is just one factor affecting what's going on in the air outside. Weather is generally made up of 6 components. Temperature is the measure of how hot or cold it is. Air pressure is how heavy the air is. Wind is the movement of air. How wet or dry the air is known as humidity. Clouds are a phenomenon that results from wet air mixing with dust and condensing. And finally, precipitation is when that water falls out of the air back to Earth. Seasons do exhibit weather patterns, and sunlight exposure does affect all 6 of these components. The better humans have been at monitoring these components and their patterns, the better we are at predicting what might happen next. Last Monday afternoon, March 1st, NASA successfully launched the GOES-T satellite into orbit. A collaborative effort between NASA and NOAA, the Geostationary Operational Environmental Satellite Program, GOES, has been observing our planet's weather for more than the past 40 years. As their name suggests, GOES satellites travel through space in geosynchronous Earth orbit. This means that satellites orbit the Earth at the same rate at which the Earth rotates on its axis, resulting in geostationary observation. So though our satellite is moving through space around Earth, this is our Earth, we know the Earth is spinning and the satellite is moving around it. But since they are in sync, moving at the same rate, that means that this satellite is constantly viewing the same location, the same part of our planet. This allows for real-time observation of our planet. At a distance of 22,236 miles above Earth's equator, it takes just 2 satellites to scan the majority of the globe. GOES-T will replace GOES-17, currently orbiting as GOES-West. GOES-West continuously monitors the weather of the Pacific Ocean, the western United States, and U.S. territories in all of Hawaii and Alaska. Virginia is monitored by GOES-East satellites. The full range of GOES-West spans from South America to Australia, the Arctic to the Antarctic. GOES-East covers the majority of what GOES-West misses. GOES satellites can send real-time observational data to Earth in as little as 30 seconds and transmits a full planet scan every 10 minutes. In addition to monitoring conventional weather, GOES satellites have proved vital in capturing extreme happenings like the recent volcano eruptions in Tonga and the Marshall Fires in Colorado. GOES satellites are even used by NOAA to assist with search and rescue missions. GOES-T, to be renamed GOES-18 after reaching full orbit, will also include instruments that monitor space weather, which, as we've mentioned on Void many times before, can have an effect on electronics here on Earth. Meteorologists use a process called numerical weather prediction to create forecasts based on current weather conditions. The more accurate and accurate the information we have on current weather, the better we are at predicting future weather. Information from GOES satellites, ground radar, weather balloons, aircraft, space, ocean buoys, all this put in the computers, they make 3-dimensional models which can predict atmospheric activity. Forecasters tweak these interpretations based upon what they know of a certain area and potential weather situations. Computers are better at monitoring fields like temperature since they are continuous, temperatures occur everywhere, but humans are better at monitoring discontinuous fields like precipitation. There can be none in one location and snowing very hard elsewhere. Local geography also plays an effect on precipitation and computer models. Meteorology is a science where the human touch is still very important. A challenge to the field is one not of human observation, but communication. Meteorologists are tasked with condensing weather into a single icon. In fact, Weather Underground meteorologist Bob Henson reported to Discover magazine that the science has outrun our communication skills and knowledge to a certain extent. The challenge now is how do we get people what they need? More information isn't always the best way to communicate. If people don't understand it, then it doesn't help. So that's what's happening in our daytime sky. Let's see what's happening tonight. We'll clear up. We'll return to today. We do not want to be in April. We are here on the 8th. We're going to remove some of those lines. And we're going to fast forward through time to, let's say, 8 o'clock. Just after the sun has set. That's 7. We'll stick with a little after 7. We still have a little bit of twilight here in the east. Regardless, we will still be able to see several bright stars in tonight's sky. Bright stars, like the 6 brightest stars you see in tonight's sky, still framing up that asterism known as the winter hexagon, an unofficial recognition of stars compared to constellations. Again, we can see some familiar constellations in tonight's sky, like Orion the Hunter, sitting here just left of this telephone pole, as well as some of the zodiac constellations that are more easily spotted, like Leo the Lion. Looking at tonight's waxing crescent moon, look to the left of it to spot the fiery red star Aldebaran, and to the right of it to find M45, the open star cluster better known as the Pleiades. Each of these can be found as the eye and shoulder of mighty Taurus, the bull, one of those zodiac constellations. Speaking of the moon, yes, we are still going back to the moon. You may have heard about challenges for NASA in obtaining rockets for the launching of future missions, but fear not. Artemis 1, the first step in America's mission to return to the moon, is still scheduled for launch in early April. We will spend much of next month's discussion discovering Artemis. If you want to know more, send your questions to Science Ben via the Danville Science Center's Facebook page, and we may just include your submission in our next broadcast. We thank you for joining us for today's discussion, Zoom into the Void for March 2022. We look forward to continuing the conversation with you the second Tuesday of next month, April the 12th. Until then, stay yourself, that's a good thing, but you should also stay safe, healthy, and curious. We'll see you next time. Bye.